Good day everyone, my name is Khesish Bhavesh.
My name is Shivannesh.
My name is Hayden.
My name is Daneshaaran.
Today we will be conducting an experiment on how red cabbage solution can be used as a pH indicator. Let's go!
So, you may be wondering, what are anthocyanins? Well, anthocyanins are natural chemical compounds with antioxidant properties and produce pigments that give red, blue, and purple fruits, vegetables, or plants their rich coloring. So, what are some of the examples of fruits, vegetables, and plants with anthocyanins? Well, in the case of fruits, it will be a grape. In the case of vegetables, it will be a red onion. And in the case of plants, it will be a red hibiscus. These are just some of the many fruits, vegetables, or plants that contain these anthocyanins. Well, in the case of our experiment, we will be using red cabbage. We'll be using red cabbage in the form of a solution as our acid base or pH indicator.
In this experiment, our objective is to determine whether or not anthocyanins can be used as an acid base or pH indicator.
To prepare the red cabbage solution, first we need to obtain about 2 to 3 leaves of the red cabbage. Firstly, we need to put this red cabbage into a hot water boiling pot to ensure it boils. For this, we need to stir it to ensure the heat is evenly distributed. Continue stirring until the color becomes darker and purple. Once the solution has completely turned purple like this, that means the solution is ready to go. Before using the solution, make sure to remove out the red cabbage residue. Now, after I have prepared the red cabbage solution, I will carry out an experiment to determine if red cabbage can be used as an acid-base indicator. Here, I have 2 solutions with me, which are honey and toothpaste. Just a gentle reminder, since toothpaste is in a solid form, we will have to add some water to dilute it. Now, I will carry it out one by one.
So now I'll be doing regarding vinegar along with detergent water. And before we add in our red cabbage, you can notice that the vinegar solution appears to be clear in color, while the detergent water appears to be reddish and pink in color. So as you guys can see, I prepared my red cabbage solution, which is purple in color. Looks something like this. And now I'll be adding a spoon into our vinegar along with detergent water. And now for detergent water. Okay, so now I have my spoon ready, and now let us mix the colors and mixtures to ensure that it's even. So now, as you guys can see, after adding our red cabbage solution to the vinegar, it appears red in color. While after adding the red cabbage solution into our detergent water, it appears slightly dark blue.
Alright, so now I'm gonna try my acid base or pH indicator, which is my red cabbage solution, and test it out on this lime juice right here. So let me just pour it in. So as you can see, the pH or acid base indicator has mixed with the lime juice and has caused the lime juice to turn from its cloudy yellowish color into this pinkish red color.
Good day guys, I'm Shivannesh here. Today, I'm going to mix the cabbage solution into these two solutions. This is the fish tank water and this is the milk. So now I'm going to mix the red cabbage solution into the fish tank water first. Once you pour the red cabbage solution into the fish tank water, stir it. And now, you pour the red cabbage solution into the milk. Hello there. These are the results after I mixed the red cabbage solution into the fish tank water and the milk. Based on my research, I got this result and this explanation about this fish tank water and the milk. So adding a red cabbage solution into the fish tank water will show you the pH level of the water. If the water is acidic, the solution will turn red or pink. If it stays purple, that means the water is neutral. However, if the water turns green or yellow, that means it is alkaline. As you guys can see, the fish tank water still stays purple. That means it is neutral. Okay, as I said, based on my research. So the reason is because when the color change happens, the anthocyanin pigments in the red cabbage act as a pH indicator, which changing the color based on the concentration of the hydrogen ions in the water. Next, let's move on to the milk. When I do research for this, I got some clear explanation about this. So basically, when milk mixes with the red cabbage solution, it likely to turn a bluish green color because the milk is slightly acidic. As the result, it is bluish green color. And the anthocyanin pigment in the red cabbage solution changes the blue-green in slightly alkaline or neutral solution. The exact shade depends on the milk's specific pH level, but the color shift indicates the solution has a pH that is leaning towards neutral or slightly basic compared to its initial purple state. Therefore, this milk is slightly acidic as it is bluish green color, and this fish tank water is neutral as it stays purple. That's all from me. Thank you.
So, what actually happens when anthocyanins are in acids? Well, acids actually contain a high concentration of hydrogen ions, hence they are acidic. This high concentration of hydrogen ions causes it to be protonated. When there is protonation, basically there is something called conjugation. And when there is a high protonation due to the high concentration of hydrogen ions, there is a strong conjugation. So what happens when there's strong conjugation? Well, it absorbs light in longer wavelengths and it releases light wavelengths towards a red color. So what's actually happening here is that green light, so basically green light as well as blue light, hits the anthocyanin group, and basically what that does is during conjugation you have to note that when the light is absorbed, its complementary color is released. So for green light is absorbed and red light will be released, which is what we see in our naked human eye. And as you can see here, blue, it's somewhat orange, so that's what happens. So this is why when we place the anthocyanin extract inside our acidic solution, it creates a red solution, which is what we see in our eyes. So then, what about anthocyanins in an alkaline solution? Well, in our acidic solution, anthocyanins are protonated. However, in alkaline solutions, they will be deprotonated. At a higher pH, which is when it's alkaline, there are fewer hydrogen ions, so the anthocyanin will lose a proton, hence deprotonation. Thus, the conjugation is weaker compared to the flavillum cation, which is found in the anthocyanins in acidic solution. With this weaker conjugation, the molecule absorbs the higher energy, shorter wavelength, where compared to the lower energy and higher wavelength in the acidic solution. So in the acidic solution, they would absorb the blue and green lights. However, in alkali solution, they will absorb yellow and orange lights. So yellow and orange yellow and orange light will be absorbed, and its complementary colors, which would be blue and purple, will be released, which is what we see in our naked eye. Since purple and blue light are reflected, hence our naked eye will see the solution as purple or blue. And with that, we have concluded our experiment. Before conducting this experiment, what did we know? Well, with our home products, so let me use lime juice as an example. Lime juice is acidic because its pH value is less than 7 and it tastes sour. Another example, detergent water. I know that it's alkaline because its pH value is more than 7, and by using some logic, we know that detergent is used to clean clothes and stains specifically, and stains are acidic, so alkalize, neutralize it to clean it, right? But I haven't really proved that it's acidic or alkaline, I just know that they are. And these are properties of acids and alkalis. Which leads us to our next point, which is what we want to know. So we want to know whether or not we can prove the basicity or acidity of these home products by using some type of indicator. So our last point is what we have learned. So we have learned that we can indeed use our red cabbage solution, which has anthocyanins in it, to prove the basicity or acidity of these home products. So warmer colors indicate that it's more acidic, whereas cooler colors prove that it's more basic. And with that, we can prove that anthocyanins can indeed be used as an acid base or pH indicator.